Have you ever dropped a food coloring into a glass of water? Sometimes it spreads evenly, while other times it might clump together. Well, that's kind of what happens when different molecules mix. To measure how they really mix, we use a term called the activity coefficient. In a perfect world, molecules will mix evenly, like friends at a party where everyone gets along. But in reality, some molecules stick together too much and some others prefer to stay apart. The activity coefficient, which is called gamma, tells us about how much a molecule is misbehaving compared to the perfect case.
First, we know that activity coefficient measure how much real solution deviates from ideal behavior. So the equation is will be activities equals to gammas multiplies with the mole fractions and concentration, where A is activity in component and gamma is the activity coefficient, and X will be the mole fractions and the concentration. So activity also called the effective concentrations in the chemical reaction, or concentration actually participating in the reactions. Activity coefficient will be like a correction factor and will let us know what is the actual behavior and what is really happened in the mixture or solution by adjust the concentration of the substance using gammas to find the true behavior. So next is about the ideal solution. So ideal solution means that molecules will be mixed evenly and there's no interactions between each other and their behavior is predictable based on the concentration. So gammas is also equals to 1. So move to the non-ideal solution. Molecules will be attract or repel cause deviations from the ideal behavior. So activity coefficient will be used to allow us to use the ideal equation, but still can get the accurate result. So when gammas is more than 1, will be less stable, and molecule will repel each other, making the substance more concentrated, and effective concentration will be higher than the actual. So when gamma is less than 1, will be more stable, and molecule will attract each other, and making substance less concentrated, and effective concentration will be lower than actual.
Let's look at a real-life example, which is desalination. Desalination is a process that change from seawater into water. But salt and water does not behave ideally, as salt ions hold tightly on water molecules. To design this process accurately, engineers use activity coefficient, which to measure how much energy needed to remove the salt ions from the water molecule. This helps us to save energy, save money, and produce drinkable water.
Huh?
Having trouble imagining how a molecule behave in a solution. Let's make this easier. We can refer the examples from our kitchen ingredient itself. So for the first example, I can say when you add water and ethanol, they tend to mix together and forms the ideal solution, which the gamma is equal to 1. The next example I can say is oil and vinegar. They tend to separate because the molecules do not like each other. So the gamma is more than 1. And then the last example I can say salt and water. Salt indeed dissolve in water, and because they have a stronger forces between them, and then the gamma is less than 1. So what's the takeaway from these examples? The activity coefficient describes how the molecule behave in a solution from the ideal solution behavior.
So why do chemical engineers care? Chemical engineers design systems to mix, separate, or react chemicals in factories, power plant, and medicine production. So if we assume that the molecules can behave perfectly, but when they don't, so we might get the wrong result. So this might lead to using too much energy, wasting materials, or even money, or even can cause the damaged equipment and the safety problem. So by using the activity coefficient, we can design the process that are more safer, smarter, and more efficient.
Okay, so what did we learn today? The activity coefficient is a small number, but it has a really big job. It helps us to understand how the substance really behave in mixture. So this might not be perfect, but it's play an important role in maintaining the accuracy for the chemical engineering calculation. So that's all from us. Thank you for watching.